Yesterday I did number 14, so we're going to start with number 15. And notice here it's expecting me to multiply these three radical expressions. Now, again, I'm not going to try to multiply 2 times 8 times 27. What's going to work out better for me is if I go ahead and break it down. So I definitely have to multiply the numbers that are outside the radicals. So I could go ahead and multiply the 3, the -2, and the 3, and that's going to give me -18. So let me go ahead and just take care of those numbers that are outside first. Now what I'm going to do is break down and look for pairs of what's under the radical. So I could bring down the 2. I can't break that down. The 8 is going to break down into 2 times 4. The 27, I could break it down into 3 times 9. Now, I'm not at prime yet, so let me keep going. So this 2 is prime, this 2 is prime. The 4 will become 2 and 2. The 3 I'll bring straight down, and then the 9 will become 3 and 3. Now I can go back and look for my pairs of numbers. So I have a pair of 2's right here. I have another pair of 2's. And then I also have a pair of 3's. So all these pairs that I just made out of the, so I'm going to bring straight down the -18. Out of this pair of 2's, a 2 will come out. Out of this pair of 2's, a 2 comes out of the radical. Out of this pair of 3's, a 3 is going to come out. And then this last radical 3 down here on the end, nothing to pair with, so he stays underneath. Now I need to go back and multiply 18 times 2 times 2 times 3. Now, the order that you multiply here doesn't really matter. So what I'm going to do is I'm going to just multiply 2, let's see, 2, 2, and 3, and that's going to give me 12. So then I just have to do -18 times 12, and that's going to give me -216. So my final answer here is going to be -216 radical 3. Because if I decided to multiply at the very beginning, the 2 times the 8 times the 27, then I would have gotten -18 square root 432. If I multiplied these 3 numbers at the beginning, which then I got to go back and break down 432 anyways. So it's a lot easier if you just leave them unmultiplied and then factor them when they're smaller numbers. Let's try number 16. This one's division. Or again, you can think of it as simplifying the fraction. So again, when you simplify these fractions, you can only simplify numbers that are under radical with another number that's under a radical. So I could actually reduce the 6 over 90. I can divide them both by 6, and this is going to simplify into 15 square root 1 over square root 15. So dividing this by 6 gives me 15, and this by 6 gives me 1. Now I could also figure out the square root of 1. It's just 1. So this just becomes 15 times 1. And then I've got the radical in the denominator. Remember, the rule is you can never ever leave a square root in the denominator. So what we have to do is rationalize. So in order to rationalize this, I need to make that denominator a perfect square. So what I'm going to do is multiply it by the same radical that's in the denominator. So square root 15 over square root 15. Essentially, that's just a 1, but it does, modify my answer here. So the numerator, the outside white 15 times the inside yellow 15, I just put them side by side. And maybe I can change this to white so you can see where it came from. And then the denominator, notice you've got a pair of 15s here, so then the 15 just comes out. Now, I have a 15 outside of the radical on the top and a 15 outside the denominator, so I can also reduce that because 15 divided by 15 is 1. So my final answer here is just, it ends up being 15 over 1. Whenever there's a 1 in the denominator, it's just whatever's in the numerator. So this final answer is just the square root of 15. Now, when you add and subtract radicals, you need to have exactly the same radical. So for example, when I want to subtract a problem like this, as long as they both have the same number under the square root, you can subtract the coefficients. Sort of think of radicals like variables. So all I'm going to do here is do 8 minus 6, and I get 2 square root 3. Sort of think of this as being 8x minus 6x, and then when you subtract something like that, you would get 2x, where x is really your radical. So treat radicals when you add and subtract like variables. All you're going to do is add and subtract the coefficients. Let's try some more. Again, all we're doing is just practicing all of these skills. Number 18, we need to do some subtraction here. But notice right now, looking at this problem, notice my radicals, or the numbers underneath the radicals, are not the same. But I can simplify the square root of 24. I can break that down. So you must first sometimes simplify the square roots before you try to start adding and subtracting. So I'm going to simplify the square root of 24, and I can break the 24 into 4 times 6. Let me just rewrite the rest of the problem. Now, for those of you who are good and recognize that the square root of 4 is 2, you don't really need to keep going till it's prime. The square root of 6, it would break down into 2 times 3, and neither of those are perfect squares, so the 6 would stay. So I'm going to pull out the 4, as the square root of 4 is 2. 6 will stay underneath. I need to multiply these two numbers that came out. So this will become a negative 4 square root 6 minus 3 square root 6. Now I have exactly the same number under the radical. Now I can deal with those coefficients. So negative 4 minus 3 gives me negative 7 square root 6 as my final answer. 19, I'm going to need to do exactly the same thing. I'm going to need to simplify those radicals first. Yes. So again, I'm trying to add these two radicals, but they're totally different numbers. So I need to simplify them. So I'm going to simplify 45, and I can break this down into 9 times 5. The 3 is already outside. Now on the next part of the problem, if you recognize that 36 is a perfect square, you can just square root it. If you didn't, you would factor it, and then you could make a pair. So I'm going to just go ahead and square root 36, and it becomes 6. Now I'm going to go ahead and simplify the 45. So out of the 45, the 9, I can square root it. It becomes a 3. 5, nothing to pair. And then I'm going to multiply the 7 times 6, because both of these numbers are out of the radical now. Also over here, I have 2 numbers out of the radical, so I can multiply those as well. And now I'm at the point where I need to try to add this. However, these are not like terms. The 42 does not have a square root of 5, so I cannot add that together. That is my final answer. So I can't add a radical to a number. The number would have also needed to have the exact same radical. Number 20, we're going to do the same thing. We're going to simplify the square roots first, and then, if possible, we'll go back and add the like radicals. Everybody good on 19? Try 20. So I need to break down 32 and 63. I'm going to break 32 into 16 times 2. You could have also done 4 times 8. If you would have chosen 4 and 8, you would have had to keep breaking the 8 down. For 63, I'm going to break this down into 9 times 7. Now, because I'm able to find the largest perfect square, that's a factor of it, I'm just going to take it to the square root. If you have not picked the largest square root, then you're going to keep breaking it down till it's prime. Everybody with me on that? All right, so square root of 16 is going to be 4. The 2 is not perfect and nothing to pair with it, so I'm going to leave it under the radical. The 9's a perfect square, turn that into a 3. 7's prime, leave it underneath. So now I have to go back and multiply the numbers that came out. So this will become 12 square root 2. And then I'll multiply these right here. And this becomes 12 square root 7. Notice that they do not have the exact same number under the radical. So I stop. I cannot combine them because they both don't have a square root of 2 or they both don't have a square root of 7. For 21, we have 2 binomials here. If you recall from your Algebra 1 days, your teacher might have told you an acronym called FOIL. Okay, so you can either choose to use the acronym here or just do distributive property. So whenever I see 2 binomials that I need to multiply, I think FOIL. So I'm going to be multiplying the first terms together. And again, if you don't like FOIL, you just distribute. So 4 times 4 gives me 16. And then I'm going to do the 2 outside numbers, which is the O in FOIL. So 4 times negative square root of 11. When you multiply radicals, they don't need to have the same radical. So I just put the outside next to the inside. So I would just put 4 and then the square root of 11. And now the inside numbers are going to be square root of 11 times positive 4. And again, put them side by side. And then finally last, I'm going to multiply square root of 11 times negative square root of 11. I got a pair of 11s, so I know it's just going to come out of the radical, and a positive times a negative is a negative. Now I can go back, and if you recall from your Algebra 1 days, that outer and inner could usually always be combined. In this case, when I try to add the green and the blue, the negative 4 square root of 11 plus 4 square root of 11, this is going to cancel. And now I'm only left with 16 minus 11. And I can do that because they're just numbers. And my final answer here is 5. This is going to lead us into the complex conjugate that we're going to be covering. And that'll end up getting a radical out of the denominator when you've got 2 terms going on. The next one is a binomial squared. And I'm going to show you the common mistakes when students see a binomial squared. Once they make this mistake on the first quiz or test, trust me, you won't do it again. So let me show you what to do with number 22. Everybody good on 21? 22, binomial squared. Do not be tempted to just take this power of 2 and put it there and there. Remember what something that squared means is we're going to write it 2 times. So we're going to write it down twice and we're going to FOIL it. If you just try to distribute that power of 2 to those 2 numbers, you're going to miss out on that middle term. So whenever you see a binomial squared we're going to write it down 2 times and we're going to FOIL, or do distributive property. So we're going to go ahead and multiply. First, I'll do the outside times outside. So that'll give me 3 times 3 is 9. And then square root 7 times square root 7, I've got a pair of 7s. So then the 7 comes out of the radical. And then the next term will be the outside. So again, I've got 3 square root of 7 times negative square root 3. I'm going to multiply the 2 inside numbers, or the numbers under the radical. So 7 times 3 is 21. The 3 was outside the radical, so I just leave them there. Now I'm going to do the 2 inside numbers. Negative square root 3 times positive 3 square root 7. This is going to give me 3 square root 21. And then finally last, negative square root 3 times negative square root 3. Negative times negative is positive. Got a pair of square root 3's, so the 3 just comes out. Because really what we're doing is 3 times 3 is 9. Square root of 9 is 3. Now, when it's a binomial squared, those inner and outer, those 2 middle terms are not going to cancel. So I can combine these 2. Again, they have like radicals, so I'm just going to add the coefficients. So I'm going to actually multiply the green. 9 times 7 is 63. I'm going to add the coefficients in the middle, and this will become negative 6 square root 21. And then finally, that last plus 3. The only thing I can combine are going to be the 63 with the positive 3 at the end. So I'll go ahead and add those, and I get 66, and then minus the 6 radical 21. I can't combine anything further because the 66 does not have a square root. Pretty good there? All right, let's keep going. Now this next slide, and it's sort of out of order. So we've already been doing this. So whenever you end up with an answer, and if there's a square root in the denominator, we've got to eliminate it. And this process of eliminating the square root from a denominator is called rationalizing the denominator. So for example, and we've already done this, to fix the first example, to get rid of that square root of 2, I'm going to multiply the numerator and the denominator by the square root of 2, because then that makes that denominator a perfect square. Got a pair of square root 2's. It comes out. The numerator, the 5 is out. The square root 2's in. So I just leave it like that. So the final answer here, after it's rationalized, is 5 square root 2 divided by 2. Now, the bottom one we have not seen before. When you have an expression in the denominator, meaning 2 terms, in order to eliminate that square root 3, I am going to multiply both the numerator and the denominator by what's in the bottom, but with an opposite sign. So if it's an addition, what I'm going to multiply, and let me just rewrite it down here so I have more room. What I'm going to do to rationalize this is I'm going to multiply it by the same numbers that are there, but instead of an addition sign, it'll be a subtraction sign. Because if you recall, back from example number 21, when I FOILed it, it ended up eliminating the outer and the inner, and that got rid of it. So what I'm going to do here is I need to FOIL the denominator, but the numerator I'm going to distribute because it's just a number times a binomial. So for the numerator, I'm going to distribute the 2 to the 2, and then the 2 to the square root 3. For the denominator, let me just show you the whole FOIL process. But bottom line, when we're doing this, all we really need to do is first and last, but I'm going to do the whole thing. So if I do first, 2 times 2 is 4. Outer gives me negative 2 square root 3. And that's hard to see. Let me bring back a color. Bring back black. So when I did the outer, I got 2 square root 3. The inside gives me positive 2 square root 3. And then last is going to give me radical 3 times negative radical 3, which gives me minus 3. So now, let me put a negative sign here. So now, when I go to combine my like terms, these cancel. So now I'm just left with doing 4 minus 3. And the denominator, after I multiply those two, is 1. And then anything divided by 1 is itself. So the final answer here is just 4 minus 2 radical 3. Let me rewrite it down here. 4 minus 2 radical 3. Now, so bottom line, whenever you're trying to rationalize a denominator that has an expression, you're going to multiply it by exactly the same expression, but an opposite sign. Once you go to do the FOIL process, only do first and last. Don't worry about outer and inner, because outer and inner are always going to cancel. So let's try a few more examples, and then we're done. So the next one, again, all we need to do is the normal rationalize. We need to make that denominator a perfect square. Fastest way to do that is just to multiply the numerator and the denominator by that denominator to make it a perfect square. So 3 times 3 is 9, or you got a pair of 3's, so the 3 comes out. For the numerator, I only do inside with inside, so it becomes 7 radical 6. Nothing can be simplified here because the 6 is under the radical and the 3 is out. If I could reduce 7 over 3, I would, but that's my final answer. Going to do the same thing on number 24. My goal again, and 24, is to get rid of the square root of 3 that's in the denominator. So I'm going to multiply the top and the bottom by the square root of 3. So really what I'm doing here is distributing the square root of 3 to both of these. The denominator just makes the 3 come out. So then when I distribute the square root of 3 to the 4, 4 is outside, so I just write them side by side. But the second part, the 2 is under the radical and the 3, so it becomes square root 6. Nothing here can be simplified, so I'm done. Number 25. Here's where we're going to use that conjugate, or the opposite sign, because 25 has an expression. So I can't just multiply the top and the bottom by square root 2. When it's got a binomial like this, I'm going to be multiplying it by the opposite expression. So I flip the sign. So now 1 times anything for that numerator is just itself, so 3 minus the square root of 2. Shortcut for the denominator, all you need to do is first and last, because if you do the whole FOIL, outer and inner are going to cancel. So first is 3 times 3, and then last is square root 2 times negative square root 2, which gives me negative 2. I can go ahead and subtract that denominator, and I get 7. And I'm done. And then the last example, another one where we're going to multiply by the conjugate. But this time we have to FOIL both top and bottom. But again, remember, for the denominator, just do first and last. The numerator, we got to do the whole FOIL. Pretty good? if you're not sure, whenever you're multiplying two binomials, just do the whole FOIL. You know, even though you're going to do outer and inner and see that it cancels, it's better to do it if you're in doubt, and then, you know, sometimes you'll get an answer. Let's try the last one. Again, I want to get rid of that radical 2 in the denominator, but in order to do that, I'm going to multiply the top and the bottom by the opposite expression of the denominator. So notice what I'm doing here is multiplying two binomials in the top and in the bottom. So let's go ahead and go through it. So I need to FOIL the numerator. So for the numerator, first gives me 3 times 1. The outer gives me 3 times radical 2. The inside gives me radical 2 times 1, which is just going to be 1 radical 2. Now, the reason why I showed you the 1 is you could have just written this as radical 2, but when we go to combine that blue and white, we're going to need to remember we're adding coefficients. So then finally we'll do last. And will the red show up? Radical 2 times radical 2 is just going to give me positive 2. That's just for the numerator. Now, if you're not sure when you see something like this for the denominator, you could do the whole FOIL. But whenever you multiply two binomials and their opposite expressions, just do first and last. You can do the whole FOIL, but outer and inner are always going to cancel. So 1 times 1 is 1, and then last, negative root 2 times positive root 2 is just minus 2. Let me go ahead and combine my like terms here. So in the numerator, I can combine the outer and the inner here. Remember, you can only add things when they have like radicals. So I'm going to add just the coefficients, so 3 plus 1. And then I can also combine here these numbers. So then final answer here, once I do this, I'm going to get 3 plus 2 is 5. And then these 2 in the middle become 4 square root 2. And then the denominator becomes negative 1. So now what I'm going to do is simplify this, and I can divide both of the numerator terms by negative 1. So final answer would be negative 5 minus 4 radical 2. And that is it for the notes on P2c.